two sets, A and B. How do you consider two sets? It's also whose elements may be any objects whatsoever. Well, you draw a picture. My picture here, this is set A and set B. And then the definition goes on to say whose, that D is, I didn't like that circle. Thank you, thank you. Here we go, B. Now the B is too small, but we gotta move on. Whose elements may be any objects whatsoever. This is whatsoever. Okay, all right. And suppose, so here is our first suppose, and suppose that with each element x of A, so let's put x in there. So we have right here, this dot could be anything, right? It could be a point, x comma y. It could be an apple. It could be a car. It could be a bad Palestinian. Now that's a good joke. But we don't recognize their humanity, so we're going to give them the letter X. Because, Palestinians are not woke enough. If they had just become fully woke, that's the past tense of woke. Yeah. And that's why Russians used to be woke, and then we said they weren't woke. Now they've become anti-woke in reaction to American imperialism. Every good thing that has come from here is now used. Human rights was used. Now woke shit is being used. Next thing you know, they'll be using chicken curry against people. Throw that chicken curry at him. Kill him with chicken curry. Yeah. Yes. All right. So next, sorry, did I say that loudly enough? Next. Here we go. So I put that here, and then this is the business here. It says then f, remember this is the definition of function. So let's come back here. Consider two sets, A and B, whose elements may be any objects whatsoever, including bad Palestinians. Oh shit, I'm recording this. Thank God nobody watches my channel. So suppose that each element X of A, and suppose that with each element of X of A, oh shit. I did not write the most important line here. So I'm just going to make that up. Is associated, I think that's what the book says, is a associated number or object f of x in set B. Somehow I did not write that down. All right, and maybe it's actually, oh, here we go. I have the definition here. Oh, okay. So, and suppose that with each x of A, and I am deleting this and fixing this because I have the definition in my hand now. So the writer goes, the math professor here goes, with each element of x, there is a, let's see, why am I having, there is associated. So in other words, with this x here that is in set A, there is associated in some manner an element of B which we denote by f of x. All right, so we have an element here. So first we think of two sets, and then we say that these sets can have whatever elements. We identify one of the elements in A, and we give it the symbol x, the variable x, and then we say that this x somehow is associated with this value here that we denote by f of x. Okay, so all right, so and then we need the function f. So now I'm going to write this next line, which goes, if this is true, if you have an x in set A that is associated in some manner, something happens to this and it gets associated to this thing here, then we can say that this thing here, we have to explain it. How is it that this is related to that, right? So then we say, then well, I'll use this. F is said to be a function from set A to set B. So in other words, there is, let's use this, and we have a function f. That is, and it is connected in some manner. So what is that some manner? This function, some manner, maybe square it. In other words, the formula for this function could be x squared, right? You guys have seen that, right? F. You stick in 3, for instance, and you get 9 on this side. 3 here is associated with 9 over there. -3 is also associated with 9 over there. Because they both, if you apply this formula, will get you the same value. So this arrow thing, arrow is fine. You can have multiple objects here associated with a single object here. That is still a function. What you can't have is a single object giving you 2 answers. Sometimes it says, if you put 2 into the function, sometimes it gives you 4 and sometimes 23. That is not a function. Okay, all right. And then there's some more terminology. So this is a function from A, and I messed this up. No, 2B. Okay. Another way to say what's happening here is this. We can say then f is said to be a function from A to B, or a mapping of A into B. So this thing here is the key thing here, because, for instance, what if there were 2 objects here, for instance? There's another object, let's call it Y. So everything here maps to something here. Into means it maps into this B, but not to everything, not to all. So all from here go into some of here. That means into. In other words, I could say for A, I can put all here, all into some elements of B, but not all. Okay, when you have this kind of situation, anyways, so there's the onto. Onto would mean that everything has an arrow coming into it. Right now, as it is, this is a mapping which is an into mapping, where everything that is in the domain here is mapped to something here, but some elements of B are left out. If every element of B had an arrow coming into it, then this function would be an onto function. Right now, what we have in this picture and this definition is giving us a, at least up to now, a definition of an into function. Okay, onto means we are on to you. We're on to every element in B. Okay, and then there are other terms we'll look at that say the same thing. So set A is called a domain. I'm not going to write that. This is called a domain. And this is not in the PowerPoint I sent out, but I'll add it, like with the pictures and stuff. So domain of F, that's what this guy is. A is the domain of F. Or we can say that F is defined. Let me write that here. F is defined on A. In other words, take any element of X, of A, and you stick it in the function will spit out and give you a value. Okay. This function will take anything from here. In other words, this function of squaring is defined for each element of this set A. So this is the second way of saying that. So what's the first way of saying that? That we have a function between A and B, and A is the domain of the function F, or function F is defined on A, same thing. And then the other thing is that these elements here are called values of F. Okay. And one last thing, the set of all values of B is called, anybody remember? So you got domain, there are two terms for it, and I always confuse. So if this is domain, this is the range or codomain. Okay, so this was our first thing. Now let's go do some pictures before we go to the next definition. And pictures are not here. Here we go. All right, so. And so when you're doing math later on in your life and you're dealing with functions and sets, remember, one way to think about it is in pictures, because that's really helpful. Otherwise, it's easier to remember a picture than some words. Oh, Ellie is here. Excellent. You want to sit over there, Ellie? Yes, good. All right, so let's do this one here. Injective functions. This is just some vocabulary with some pictures, and it's important to just memorize, be able to remember these pictures, because that will help. Or we can call it injection. Okay, so we've got a set here, and we've got another set here. And we have 4 elements here represented by these dots. And we have a function that takes these elements from the domain into the range. And let's see, how many did they put here? So we've got 1, 2, 3, 4, 5. All right. So this is a, why does it call it 1-to-1? I'm going to call it into. So my notes are wrong. Let's just call it into. Actually, the internet was wrong about this. So we have a set represented by this egg here, and this element here is mapped into this guy here. Yes? This one is mapped to this guy. This goes here, and this one here. So what you have is an injective function. You have injection going on where not every element in the set B, let's just call it B and A. So these would be our x's, right? And these would be our fx's, f of x. Not every element is getting a arrow. Not every element has an arrow going in. So this is a picture where we can say that this is a injective function, or an injection is happening between two functions, two sets. Okay, all right. So that's number 2. Number 2 is surjective. So I'm going to write it here. Surjective and or onto function. And onto function says that, so a surjective function or surjection says that if this is into, we go into, so this is all here into some. And what we're going to have here is all onto all. So we have 4 elements here according to this picture here, and only 3 on this side. Yeah, this is surjective. So this is thanks to French mathematicians. Came up with this. So in the English-speaking mathematical world, we were happy with into, onto, one-to-one mapping, and then the French showed up, and they're like, no, British. That's not a French accent. How I shouldn't. Okay, so here we go. Whoa and whoa. Is that fine for a function? Yes. 3 becomes 9 here, minus 3, 9 again, if it was x squared, for instance. And then we have all. So all of these better have arrows coming out of them. This goes right here, and we are done. So this is onto. So this is our set A, this is set B. Every element in set B will have an arrow coming into it. And that is why this function here is a surjective function. Here, we could have also had 2 things going into the same one, right? Let's just do that, right? Let's put another x here. And now you have 2 elements of the domain going to the same one, as long as one of the elements on the range in set B is left unarrowed. Okay, as long as there's one element which doesn't have an arrow going into it, then we can say all into some of the values here. And here we make sure everything gets covered. So these are the 2 things. The third thing is called bijection. So if you're reading mathematical textbooks, you're going to run into this stuff. Let's put bijection here. Bijection is kind of like when Great Britain and America get together for a killing spree. Like nothing. Fucking Great Britain. I reject there. Reject them. All right. All right. So we're going to have two Aggies. Again, set A, set B, and my picture did what? It did the right thing. Yep. We got 1, 2, 3, 4. 1, 2, 3, 4. So a bijection is onto and one-to-one. Okay. Oh, that's why they call it one-to-one. I see what's going on here. So I think I'm going to take this out. Sorry, folks. Okay. And I'm also going to put here one-to-one. So these notes are correct. Okay. So I'm going to rewind and let's go back here. Why is this one-to-one? Because every value in the domain has only one arrow coming into it. And one of them is left. So therefore, it's into, it's one-to-one because there's only one value for each input. This X only has this point here. This one, only this one. While over here, this is not one-to-one. So I'm going to say one-to-one, not. Because one of the elements in set B has two arrows going into it. If you have one arrow going between two elements, then it is one-to-one. All right, sorry about this confusion here. This is into. Why is this into? Anybody? Because something was left out. Why is this onto? Because nothing was left out. Why is this one-to-one? Because each of the functional value gets only one arrow coming into it. This one is not one-to-one because there are two arrows going to the same functional value here. Okay. So now what we do is we look at bijection. Bijection is a function which is both, move here. Bijection is both onto and one-to-one. So it takes the, sorry, onto is like this. It takes the idea of onto from here. In other words, everything in set B better have an arrow coming into it. And it is one-to-one where only one arrow will go there. So we have memorize this, folks. It's very useful. Even though not in this class, but if you take my next class. Yeah. Okay, how good are we with this? Solid? Okay, do not forget, this is how we'll survive the Holocaust. It's, or the apocalypse, or whatever is going to happen to us, as in Costco shutting down. Oh, good. Take a picture. It's also in your inbox. But this is actually better because it doesn't do this. All right. Now I'm just going to do one more definition because we'll probably run out of time. Right. Oh, excellent. So we'll do the whole thing then. I mean, just the definition. And then next week, we're going to do limits of functions and then jump and continuity. And then as soon as we're done with that, differentiation and integration. So that's all that's left, folks. Your wild trip into mathematics is almost okay. So make sure your boyfriend doesn't get people to vote for Miss K. And not Miss T. Yeah, the feminine side of Trump, as Vincent would point out. Actually, even when I was young, I went to a doctor, he said, "You're very sensitive." I'm like, "For you." Uh, I was a little, yeah, it's like, "You're so sensitive." I'm like, "Hello." Yeah, how did shit. All right, so this is a okay, so this is a definition of terms like what is an image? And I don't really understand any of this, but we're going to continue doing this. Image and range. Okay, so definition starts. Again, we are looking at how mathematicians talk about things. Let A and B be two sets. So obviously A is going to be the domain, B is going to be the range, and let F be a mapping of A into B. Notice the word into shows up. What's another way to say this last bit? Let F be a mapping of A into B. According to what I just wrote earlier, F is defined on A. Okay. Mapping of, so F is what? What kind of creature is F? It's a mapping. What's the other name for F? Starts with F. Yes, very good. All right. Thank you. Now, so should we draw E and B, A? Okay, so let's do that here. Here's our A, and here is our B. Actually, this time I'm going to use colors. So we're going to have B is in red. We've got A. Let A and B be two sets, and let A function be a mapping. So we can just throw in this line here, right? Here's our function. What does this function do? Associate elements of set A with, in some manner, with elements of set B. Excellent. Now, here comes complication number one. If E is a subset of A, if every element of E is in E is a subset of A, which means E can be in here. So I'm going to throw E in here, or put Mr. E in here. All right, so we got a set A, which has its own elements, dot, 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 dot. And some of the elements of A are also in E. All right. Then if we took all the elements of E as inputs to the function F, one after another. So what are we saying? We are putting the set E as the input to function F is defined. So set, so if E is a subset of A and sitting there, then F of E is defined to be the set of all elements Fx. Okay, so how do we, at this, so all we have right now is this thing, right? We have the set E, and what they're saying, and this is how I drew it, because there are no pictures in this stupid textbook. Here we go. Ooh, I need, looking at the wrong thing here. Okay, here we go. So it says F of E is defined to be the set of all elements F of X for X belongs to E. Yeah, that is not helpful. So I'm going to put And if E has these elements, X and X, what are the elements here then? These guys. And they look like what according to the definition? So the only thing that the definition doesn't tell you is where where this set is. It really doesn't say that. But yes, folks, anybody? Hint. Little guys, f of x. So what's happening here? These x's are being mapped into these guys here. Okay, so in other words, the earlier pictures, we just had a set A and set B. And now what we have is in those sets, we have subsets. The subset here, its name is set E, and this subset is f of uppercase E. The reason why we're doing this is that when you go to metric spaces, this will be a metric space A or metric space X. This will be metric space Y. And then this will usually have a subset E in it, and you will be dealing with set E all over. So this is kind of like a what we will not be doing that in this class, but if you come to the dumpling Fridays and Saturdays, I'll be doing that stuff over there. We will now call, remember, we want to find this thing. We call the set of all images of the elements of X. So f of X is an image of X. This f of X is an image of this X, whatever its value is. These are different. I could put, it will make it very complicated, but here we go. This f of X is an image of this guy right there. So this is a set of images of set E. So we call the set f of uppercase E, the set that you put in as the image of E under F. This is just this kind of concept right here. All right. And then f of A. So I'm going to write it here. Uppercase A. What is f of A? You take the function f and put all the elements of A, 15 and 16, all the elements one by one into the function. And what you get back is all the values. Not all, but some of the values, because so then f of A is a range of f. This is where Ryan might come and help me out. The range means everything has an arrow coming into it. Does it? No, it doesn't mean that. No, it means all the elements that could get an arrow but not necessarily get them. Image is the one that actually is an image of something here. I think there's that thing, and then it says it is clear that's what the book says. It is clear that f of A is a subset of set B. So everything in A and the values that A gets on this side, these f of x's, not all of them, but some of them. That's the range. And I think I should stop because if this is equal to this, sorry. Okay, let's back up. What does this mean? If f of a is the range of f, it is clear that f of a is a subset of b. What's the other way of saying that we just saw? So let me draw a better picture. So we have this going here. And then all the x's in A, one went here, one went here, right? These two guys were left unarrowed. So if you stick all the values of set A into the function, that is the range. So what is the range right now? 1, 2, 3, 4, 5, 6. And 2 are, these 3 elements of set B are not in the range. Therefore, f of A is a subset of B. It is smaller than, it's not equal to. Which means we are talking about what kind of, is it injective? So this defines our notion of into and our notion of injective. And then when does this become surjective or onto? This becomes surjective or onto when f of A equals B. In other words, there were 3 more things in the domain. And all of these guys, so every element of B has an arrow coming into it. When f of uppercase A equals the set B. All the values in this set here, what are the values of this set? They look like, what is B? B is also this, right? If these two sets are identical, then it's onto because all have arrows coming into it. Versus if the range is only a subset of the codomain, then it is into. Is that kind of clear? No? Okay, I'm gonna go over that, but so what I'm doing is when Rudin talks about injection or injective functions, he says this. When he wants to talk about surjective or onto, he says this. And that's all I'm saying. And so then we went through the definitions earlier on. Rather than clearly just fucking tell us what he's doing, he just says that, and I have to draw the picture and figure it out. But Ryan, you were saying? Yeah. Ryan is having fun. So this is saying all elements of set A were mapped into some elements of B, leaving some alone. Because the range was a subset of B, was smaller than, and then this guy is saying all of A into all of B. All elements of A got mapped into all elements of B. Nothing had, there was no element in B that didn't have an arrow coming in. I'm going to repeat this, okay? Because this is kind of cool. If you can get this right now, it will make your life very easy in the world of mathematics. So Wednesday, we are actually going over the exam, 2, but 1 actually. I'll come back to this. We'll write it down and I'll send out the notes. Email me. Yeah.